our manhole to manhole lining using our F-10 Top Gun. This unit is designed for your 6-inch to 12-inch pipelines, and it's going to be a little bit different than the inversion system we utilized yesterday. Where yesterday we were using an inversion system that is a drum, this is going to be what we consider a continuous inversion unit. The drum is going to be great for our laterals, but it's going to restrict the length of pipe that you can line, whereas this unit's going to allow us to line 500, 800, 1,000 foot runs in one shot. Give me a louder. Test. All right, so whereas yesterday we were rolling everything up into the air inversion unit, which is a pressurized drum, this unit, our F-10, is going to operate much differently. Incorporated inside of the unit itself is going to be an internal bladder. Now this is going to be a silicone-based bladder that we're going to hold a minimal PSI on. We've also incorporated a self-oiling ring that's going to introduce basically vegetable oil to act as a lubricant. Now yesterday you saw us basically wet out within the truck. The polyester resins we're going to use today are going to be a little bit different. We actually wet out this liner material at a wet out facility and deliver it directly to the job site. So if you have a 500 or 1,000 foot run, we can wet that out at the facility and deliver it right to your door. Now the difference between the epoxies and the polyesters are going to be that typically the epoxies that we're utilizing for the laterals are going to be a 0% shrink. Now the polyesters are going to have a slight shrinkage property, but they're going to be more stable in a climate controlled environment, as well as the polyesters are going to be about 1/3 of the cost. When you're dealing with 8-inch to 48-inch liners, you're going to save a great deal of money by utilizing those polyesters. And if we were to have some unforeseen liability, say a hurricane rolled in or a storm, our liner material is going to be good in the refrigerated truck for up to 60 to 90 days, whereas the epoxy is going to be less stable. Being that we're using so much more resin in the liner material, that's why we wet it out at a wet out facility. And this is all going to be vacuum wet out, which is a similar process to what we did yesterday in the back of our demonstration vehicle, but it's going to be done on a much larger scale.
Come back a little bit.
So the way the wet out facilities work is that they're actually going to take the length of liner for the specific job, and they're going to mix up a batch of the polyester blend resin. They're going to pour that inside of the belt liner material, and they're going to run it down a conveyor table that has material pinch rollers. These pinch rollers are going to be designed for an even thickness, and as this runs through the line, they're going to use vacuum pumps to help pull that resin into the belt material. As it goes through the line, they're going to just move the vacuum pump down, and they're going to roll this right into a refrigerated vehicle. Now the coatings on this material are going to be a bit different than what we had yesterday as well. Because we were inverting much smaller diameters, we needed a much softer coating, and that's where we incorporate the PVC flex coating for our lateral material. Typically in a mainline, we're going to use either polypropylene material or a polyurethane coated material. It's going to be much more rigid, but it's also going to withstand the steam. In our laterals yesterday, you saw that we were utilizing a calibration hose to act as our bladder or balloon. We have to do that even if we had access to both ends of the pipe, because the PVC coating is so much softer, steam would actually bubble that coating, whereas the polypropylene or the polyurethane will actually hold up to steam. We do not need to actually use an internal bladder with this material. We're going to use air pressure to invert this here today. We typically use air pressure to do all of our inversion up to 36-inch. Anything typically over 36-inch, we're going to switch over to a water inversion and use water to invert this material. So you can see here the guys already have the material. It's coming to the job site wet out in the refrigerated truck. What they're going to do is place that material over the roller, pull it through this internal bladder and cuff it back and clamp it on. Once they introduce low pressure to this bladder, they can put a higher amount of air pressure here, and that's going to cause the liner to invert at a rather quick rate of speed as it slides through that bladder. Now, prior to any of these installations, what we've done is, of course, cleaned and removed any debris from the existing pipeline. So if there's any, it is a soft felt material, so if there's any debris in the pipeline, the liner material is going to take the shape of that debris. So we want to remove all that, typically with high pressure water jet. This is a process where we are going to need to remove the flow from the pipeline. So here today what we've done is actually just plug the line, and we have a backer on site for an upstream manhole so that if we do start to get some backup, we can remove that upstream head pressure. Now, a couple of you may have seen what the guys were doing down in the manhole a minute ago. They were actually placing inside of the pipe to be lined what we call our hydrophilic in-seal. Now, typically in the past, if you've ever seen a mainline specification, because we're utilizing the polyesters that have a shrinkage property, a typical spec has been that you need to grout the end of the manholes with like a polyurethane grout. Well, we've designed a hydrophilic in-seal, which basically looks like a burn coat that's going to fit on the inside of the pipeline. It's much thinner, and it's actually designed with a hydrophilic material so that if it becomes in contact with any water, it's actually going to swell. Your typical polyurethane grout is you could have a lifetime of 5 years up to 25 years, and what really helps that out is having moisture behind it. As the drier seasons hit, if the grout dries out or the manholes are drier, it's going to cause that polyurethane grout to get brittle and deteriorate a lot quicker, where the hydrophilic in-seals will not. Now, another thing that the guys have placed down inside of the pipelines, you can see they've got a wire that's coming out. Because we want to know what our temperature gauge is going into the pipeline and coming out, once we introduce steam, they've basically placed thermocouplers in both ends of that pipeline. The thermocouplers are going to give us a digital readout so that we know our temperatures on both ends of that pipeline. So here you can see they basically just slid the liner material through that internal bladder and cuffed it back over the bottom of the inversion head. Like I was saying, this unit, you can do your 6, 8, 10-inch pipelines with one unit. We do have units that go up to 36 inches. As you get a little larger, they're going to actually be trailer-mounted units. Now, the material we're showing today is going to be the polypropylene coated material. This is a stitched and flame bonded material. There's not a product that really will adhere to this. So as we do the vacuum wet out and they wet it out, it's rolling down the roller table, we want to continuously move our vacuum down the line towards our resin slug as it goes through that calibration roller. So they just puncture the bag with a very small puncture hole, and they've got suction cups that's going to continue that vacuum. To reseal that hole with a polypropylene coated material, you have to use what's called a drader gun. Drader gun's the only thing that's going to seal that back up, and it actually is like a glue gun for polypropylene. So because we're using thermosetting resins and the drader gun is very warm, what they want to do is basically seal their functional in for their vacuum and then use a cooling agent really quick to cool that back down, because if they have a resin slug going through the roller table, they don't want any heat starting to promote that thermosetting resin. Now, typically at the wet out facilities as well, it's going to be a visual wet out. Most of your wet out process is going to be a visual inspection, and what you're looking for, you can tell the tint is a little darker than the epoxy we were utilizing yesterday. But you're looking to make sure you don't have any dry spots, because a dry spot is going to be an area where the polyester resin is not in that felt material, and that's going to constitute a weak spot in that liner, and your inspectors will fail that region. So Steven's just going to apply those bandage straps, and that's going to be what's going to hold it to the inversion head. Once he introduces the air pressure, you'll see it's going to go very quickly. They'll coerce it into the pipe to be lined, and he's going to start introducing air pressure. Because we're inverting, you know, of course, friction's going to be our enemy, so we've incorporated that self-oiling unit. All this is simple vegetable oil. We're using that as a lubricant to help the material invert an easier ring. The ring is actually right above that internal silicone bladder. Now once we've got the liner all the way down to our other end, we'll walk down there and I'll explain this to you as we go. The liner material is going to come up out of the manhole, and it's going to be dry at that point. As this is dry, there's no resin in that. Your most expensive part of your lining material is going to be your resin. So you don't want to waste a resin-based liner material going down with you. You don't need it. So they're going to invert the dry down. They're going to have the wet out liner that goes 300 feet down the street, and we're going to bring dry material back up out of that line. Because we're steaming these, even though we've got air-water separators on the steam units, we're using two of our Viper 750,000 BTU dry steam units. You're still going to gain some condensate. Now we don't want to gain condensate in the bottom of the liner, because what will happen is it's going to be your hot liquid material that's going to keep the liner soft. So what we've done is we've built what we call our Maverick and our Goose on the other end. We can tell not only our pressure coming in and from our manifold and our steam temperatures, but we can also tell our pressure coming out and our temperature at the other end, not only from our thermocoupler, but also from the Merlin and the Goose. Now to remove that condensate from the liner material, which could eliminate a possible failure, what we've done on that Merlin and Goose, and you'll see it's on a stand down there, is we will puncture the bag or the liner material at the other end, and we created basically a venturi. We've got a pipe that comes up with our gauges on it that goes to a larger pipe and back down to a smaller pipe. So we can allow air pressure to run through it, and it'll basically create a vacuum that's going to remove all that condensate out of the liner material. We do not want that condensate left in the pipeline. Now this is a very quick process incorporating steam. Traditionally in the past, before they were utilizing steam, the traditional way was to invert your liner materials with water. But the boiler trucks that you'd have to utilize for that are very large. There was some big issues with bringing them in with overhead power lines, because depending on your depth, you have to have a certain head height to get that water pump where you need it to be. It had to be very precise, because if you were too high and you had too much water pressure on it, if you had any laterals that tied in, you could put too much pressure on the liner, and as you cured it out, you could fill those laterals with resin slugs. You're not going to incorporate as much of this utilizing the steam, not to mention it's a much quicker process, because you actually have to take that entire line full of water and recirculate it, bring it up to 175, 180 degrees for a period of 3 hours, and then slowly cool it back down. Your cool down, your bringing up the temp and your cool down process is going to be much quicker utilizing the steam, and it allows us to have much more compact equipment. So Steven's going to put the pressure on his bladder, and it's really important that the guys took the time and actually put in those inseals first. And they're a 2-inch wide span. The 2-inch wide band, I think he's doing that on purpose. The 2-inch wide hydrophilic band is really going to eliminate that necessity for grouting. You're going to see this in more and more of the specifications where the municipalities actually want these bands because they're a much more solid product and they have much longer life expectancy. The liner materials themselves are going to be all designed as per the ASTM F-12-16 specification, which is to a minimum life expectancy of 50 years. The hydrophilic bands will also meet that specification, whereas your polyurethane grout will not. Does anyone have any questions? Now you'll see also, as this inverts through, once the liner is halfway down the line, the liner's going to be inside itself and there's going to be no more liner to go through the unit. What the guys have done is they're going to place a pull strap on there. It's basically our holdback rope. Because once the liner material is halfway through the pipeline, it's going to want to go at a great rate of speed. So they want to slow that down because the faster it's going through the pipeline, if they just give this full air pressure, if there's any trapped water in a belly or anything like that, if they let this go full speed and nothing's restraining it, it can actually jump over that water and trap it in place. So they want to slow this down so as it goes through, it pushes any of the water that may be in a belly or anything down to the next manhole, and they're going to pump it out of the lift station downstream.
That's pretty much
what? Yeah, I did. Yeah, what Jeff was saying is, did I talk about the difference in resins? And like our epoxy yesterday, it's gonna be, it's got, both of these resins are thermosetting resins, so they both have catalysts in it. But by utilizing the cold temperature in the refrigerated truck, we can keep this much more stable for a suspended period of time. So if we did have inclement weather or problems cleaning the pipeline, it's going to give us a lot more working time. So that I can actually leave this material on ice in the reefer truck for 60 to 90 days if a necessity. Now the liner, being this polyester, will cure if I left it out on the sidewalk, but it's going to take a greater deal of time. You do need to, if you want to cure this in a decent amount of time, you do have to add that external heat source, whether it's steam or hot water.
So basically there is a resin is in here.
Yeah, on both of these.
Is there anything between the pipe and
no.
the wall? No.
Nope.
So
it's going to invert.
So that's a structure that's going to hold itself.
Yep. Exactly. And we're just holding the air pressure right on the material itself. Yeah, that was a very good question. He asked me if there's going to be anything in between the hose pipe and the needle punch belt. No, you're gonna saturate your needle punch belt. The coating is going to become your new inner pipe wall as this inverts, and your belt and resin are going to come in contact with your existing hose pipe. Now this material is designed to stretch in diameter about 4 to 6%, and the reason it's been designed that way is if I was to have other service laterals that tie into this pipeline, I want to be able to see them gently so that I can go back and open them up with a reinstatement tool. So he's gonna, what Steven's doing now is he's gonna coerce that into the pipe that they want to line. And you can see that this is a very, very quick process. pullback broke, because once we hit halfway, there's nothing restraining it but that pull strap. If we were to just let it go and introduce air pressure, it's going to fly down that pipeline, and we could trap any water that's in bellies or anything else that's in the pipeline that, and by controlling that speed, it's going to actually push that downstream where it'll flow down to the lift station downstream. No, they're just going to pick a full strap. The last the next pass. Yeah, so all they're doing is they're going to basically loop a pull strap, and they're going to use that to pull up on the liner material just to bend it to get it to go into the pipe that we're rebuilding. It works, they always look at me like I'm the skinniest guy. I don't like getting down there. Smallest guy. Yeah, right? Yeah. That's what they always go. Who's the smallest guy in the crew? I'm like, fuck. You're the short end of the stick on that anytime. Yeah, right? That's it. Is that no short move? Alright, we'll give you a... Yeah, what the guys are trying to do is eliminate confined space entry. Now you smell that, the odor that's coming from this when he releases that's actually going to be the styrene in the polyester resin. You didn't have that scent yesterday because there's no styrene in the 100% solids epoxies we utilize for the laterals. Epoxy would be a phenomenal material to use in manhole-to-manhole lining, but when you get to that thickness, due to the larger diameter, it doesn't become as cost-effective when you've got a good structural product in the polyester. But it does incorporate the need to place those end seals in place or use a polyurethane grout in the manholes. But the end seals are going to give you a much longer lasting product, and you're going to see that those are going to be spec'd more and more in the bids. Plus it eliminates the need to bring out a grout truck as well.
Josh, kind of explain how we're making kind of like a C, S.
Yeah.
As a door right now, they're just poking it back. Get that. You can't go straight in. You got to get kind of an angle, you know, a nice curved angle.
Yeah, what Andrew's saying is what they're doing is we can't just push the liner down and make a 90. So what they're doing is they're poking the back because they want it to be like a nice, like a C shape or a nice curve, because you're inverting the material through itself. So we want to give it the path of least resistance so that it's going to invert quickly and effectively. That feels so much nicer than yesterday.
This is typically
It's just like a mist, but it's enough where...
Good to know.
Got your shoulder getting cold yet?
Got any arthritis in that shoulder?
Yeah, ask Doug if his shoulder was getting cold yet. He goes, a lot better than yesterday. He goes, yesterday I wanted a heated liner. typically they're keeping these reefer trucks, 34 to 40 degrees. You don't want to put it in a freezing temperature because it's just going to make the materials too rigid. You'd actually have to let them warm up prior to installing them.
So not.
Yeah, 34 to 40. You can even go to 45. Yeah. Yeah, and typically when the liner material comes from the wet out facility, and there are wet out facilities all over the United States that we utilize, what they'll do is you see it folded in an S shape. Back of the typically in between the layers, they'll also pack ice because you don't want the resin or the liner typically sitting on top of it because yeah, there has been reefer trucks where the refrigeration went. Not to mention, that's a lot of lost money when you're carrying 36-inch liner.
What's 10 now? Let me put this in. Right. What's the best what we have? They seem more they would like to right now. Better.
Now typically in these mainline bags, like yesterday when we were using the lateral materials, we're going to typically just use a 3mm liner. One thing I forgot to mention is as the diameter goes up in the pipe that we're going to line, of course your thickness is going to go up. And we can run design calculation testings to be compliant with the ASTM for during this pipe. So that we get the But as you go up in thickness, to make the wet out easier, we use multi-layer bags at that point. Because you're pulling flying it off is just ice. Thank you. have with the grater gun and the D on it for graters, that's where they were using the vacuum to impregnate it, and they resealed that material. Migrate down to the other end, and I'll walk you through how that video comes out and how we set up the end with the modules. If you guys haven't already placed a lunch order, please get with Morgan, and she'll take your lunch order so that we can go ahead and order lunch for everyone. And in here with a slip knot on it, they're gonna pull it right out as it inverts up. What they're gonna do, and of course they've got their thermocoupler here as well that's already put in the line. Their hydrophilic end seal is already put in the line, which is gonna eliminate that necessity for polyurethane grout. What they're gonna do is they're going to actually puncture that liner material. All right, so once they puncture through the liner material, they can hook up to their hose here, and this is gonna be your Merlin and your goose. It's gonna give me not only my air pressure gauge, where I can control my pressure inside of my liner from here. It's gonna give me an additional temperature reading, as well as if I feel that I'm starting to build up condensate, I can open this up and close it and open it up. And you're gonna create a venturi here, which is gonna actually draw the condensate out of that liner material and discharge it through just a piece of soft felt. The only reason we've got the lateral material on the end today is just to quiet it a little bit and for safety purposes, because you don't want to hot water out on the road.
I won't open the next linen.
So here they're basically, as the liner comes through, they'll lasso it and coerce it, and it'll invert right up out of the hole. Now this isn't what comes up, shouldn't have a great deal of the polyester resin in it, because we just want to invert up the dry material, because like I was saying earlier, that polyester resin is your most expensive cost in this procedure. So if you can eliminate wasting it, it's going to bring your cost down as far as your insulation, profitability up, and if you're a municipality, it's going to save the city money.
No, this is all air to get it out, and then we start to steam up once we got everything hooked up.
No. On this run here today, there weren't any pilings. It's closed. All of the houses run from the front to the back. This is a straight run. Now we do have cutter. No, this is the microphone. Yeah, that fucking cake. We actually distribute the Swam cutter. It is a phenomenal reinstatement tool. We actually have a cutter truck back here. I suggest if you get an opportunity,
Keep coming.
take a
Keep
look
coming.
Yeah, we would go in. We could do one of two ways. We could come from, if there was a clean out,
Keep coming.
the backside with the boat run. Or if you have a steerable.
Not even out of the pipe yet.
The liner's designed to expand like 6%. So
Keep
what you
coming.
see is your dimple. And you want to take your measurements and pliers. I could just throw out a cut. Okay, 38 feet, I've got lateral at 12 o'clock. And it gives me a ballpark of where I'm looking for. And I typically don't go off the footage counters. I'll take hard measurements and
think you still got a bit. Still got a little bit to come. Come on, I haven't seen the water even come out yet.
Little tricks that can save you a great deal of time. And because you're bypass pumping when this procedure's going on, time is of the essence because homeowners are going to want to start using their homes. So you do have to do your due diligence prior to doing a mainline shot and inform all of the residents that they're not to use their water and sewer while you're doing the installation. I typically cut their houses off just for my own purpose of safety. Now we can also, if we had a dead end manhole, I can incorporate a calibration tube. If I did not have access at this end, I could blow that liner just like a lateral and let it blow open, and then I can blow a calibration tube through there with a port that would allow me to steam through it. So it's basically going to be a steam relief valve that I'll incorporate right into that calibration hose. It's going to allow me to do that blind shot for the main line, just like we do for our service lateral.
Nothing yet.
So they're holding back there. They're on the phones or radios.
Coming steady with it.
And they just want to go nice and slow so RJ can loop it and coerce it to come right up out of the manhole. And that's what's nice having that pullback rope because they can control it as well. If you didn't have that, there's no control because nothing's restraining that liner material. Once he hit the halfway point, if he was introducing air pressure still, it's just going to want to go really quickly. And like I was stating before, if there's a belly in the pipe, you can actually, and it's retaining water, you can actually jump that because the liner will move so fast, and you can trap that water in that belly, and it'll create a lift in the liner, which is not gonna pass or meet the specification, and the inspectors will fail that material. Does anyone have any questions? Did everyone get with Morgan and fill out their lunch order? If you haven't, Morgan's got a big menu. Walk around, go down to the other end.
Come on.
All these people filled it out with.
Come on.
They're all set.
Okay. Another couple feet. 2 feet.
It's all set up.
You're out. One more foot. Boom.
Make sure your trap goes on that side of how bad it is.
Leave it down.
Cut it out.
Come on, another foot. Another foot.
Excuse me.
Okay, right there. Hope. Hope.
Hey, what did you say?
Okay, come on, slow with it.
Wait, pulling up.
Yeah, just a little bit. Don't make it.
Sir, can I get? I'm trying to get
Come on with
this.
it.
Sorry.
Foot.
Sorry.
Wait till it comes because we don't want to slip off the end.
Yeah.
Give me another foot. Yep.
They were on this because they're in the wrong area.
Come on, keep coming.
They actually left it really. We're gonna hit that sink.
Keep coming a little bit. Try to come. Okay?
Alright guys, as it comes up, you might want to step back from this little. There's no workman's comp on this job. Fire before you hit the ground. Bring it back.
Yeah. See if it'll come. See if it'll come another foot.
Yeah, I was telling the guys, I mean, typically prior to people utilizing air to inversion liners, this is all done with water. So you can imagine how much water you're putting in that column and how slow that procedure is. The weight of the water is what's inverting the liner material. So a typical liner could take all day to do because you're also having to heat that water up and recirculate.
Another foot.
They're using 20 million BTU boiler trucks, and as well as you got to get your water column to the right height. So in a lot of the alleyways
Okay, it's coming. Come on.
and stuff where you got overhead power and utilities, you made it real difficult to boiler trucks to get here in those areas. And the further you bring the hoses, the more heat you lose.
That's a joke.
Come and stop here. Stop.
Oh, they got air down there. Yeah. So they're just talking on the radios. So all they've done is put a slip knot in there, and as soon as it goes through, they'll pull the knot and pull it and
Hang on.
Hey, do you need that pole? Yeah, these guys, we've got several, we've installed all throughout the U.S. that use F-10 units. I think they have municipalities, Penn University's put in thousands of units. And Andrew's got municipalities down in Pennsylvania. How many feet do you think New Brunswick put in? They put in probably 30 or 40,000 feet, and they've had the unit for, what, a year and a half? Yeah, so, I mean, it's a really user-friendly product. And, you know, you've got the ability to do multiple sizes. I mean, you can go up, typically, over anything over, like, we've done 48 inch, but typically I like anything over 30, 36 inch. I like water. It's just so much volume of air to keep everything moving. I think we're about to get it. Speaking of,
Come out a little bit more. Think about another foot. Another foot. Go for one
Leave it
foot.
come.
because it's so tighter diameter.
Yeah, one
it's just
foot.
like laterally 2 inches superior.
They roll right up around there. It's a good spot.
We can make it, but it's gonna be. I know.
Yeah, we're good. Yeah,
We
good
can
job.
make it.
Come on up. Come
Come
with
on up
it.
more.
We can make
Go
it.
with it.
I can make
More.
it. Because all we need is a, you know, if you
Keith, give us
inch
more.
and a half, we can manufacture it.
Another foot.
Another.
We just
Yeah, give us more.
see enough of it where people want it. And typically it's a pull line.
Good. It should come right up.
So I'm not going to use a pull line, but it's on a pull line because I want to put it.
Tell them to bring it right to the top here. We sit at the top for a
Keep
second.
going. Almost there.
Okay, hold it there.
Hold. Stop. Hold.
So they actually mid-wet out the section. What RJ's doing
What are you trying to do?
is he doesn't want it pulled up.
I want it coming out
of the
flat.
manhole. The reason being is that
You want me to hold on to
it
the
comes
strap
right out of the manhole.
This will
He's
come
not
up.
going to have a flat
Okay.
surface going
Okay,
into
go ahead.
that truck.
Go ahead.
All the way.
Alright, so he
Come on.
wants to flatten it
Gonna
out
come
and
this way,
then
boys.
bring it up so that when it
Keith,
fully
go.
cures, he doesn't have a lift in the bottom of that
Go.
exit point.
More. Shoot it. Just keep going until you say stop.
Guys, please be careful in case some of the resin squirts out. I just.
I don't have them. There are.
Back. Just in case.
Go with it. Go ahead.
Keep going.
You're out. Tell them you're out.
You're out of the hole now.
There we go.
Keep coming.
Keep coming.
Aliens. Keep coming. You
Oh yeah, the snakes.
Keep going. Keep going.
Snakes and sparklers are all I like.
Joe Deere got a good name for his car too. Rusty.
Shit'll buff out.
Keep going.
Where is your Brian?
Got holes in it, so we put.
Hold good. That's good. That's good. Stop. Yeah, we're good. Yeah, hold it. Good. Yeah, RJ said, hold on. Why would you want to do it in the dry and not in the wet? Wet still the ground is very nice. Oh, God.
So what RJ's doing now is he's going to basically puncture the material so that he can...
He said, don't do anything yet. Someone's coming down.
So he's going to puncture the material so he can insert this rod into it, and we'll hook it right to our Merlin and Goose, which is going to allow us to control our pressure, while we can also see our temperature here, as well as from the thermocoupler that actually is inside the bottom of the pipeline. So they're going to be watching these thermocouplers at both sides to know what the steam's going in at and what it's coming out at. What we want to do is get a consistent temperature throughout that's going to be enough to to start the activation in the resin, and that's when we start our cure time. Typically about 30 minutes, and then we cool down for whatever length of time that we utilize to steam. We typically cool down double that. And you're going to cool down with simply your ambient air temperature coming through the compressors. We basically just turn off the steam units at that point. I think they typically look around 150, 160.
You want them both to be the same on both ends, right?
Yeah, and then they start the clock. And it's typically around 30 minutes up to the temp. You can smell that smell. That's that styrene. You'll smell it a lot more as soon as the steam gets good. If you've ever been in like a boat shop or a surf shop where they're using the resin, that's typically, you're going to smell that in your polyester you're buying it. You don't have that in the epoxy.
That's the first time I've seen this. I do.
Yeah, so you guys couldn't hear me. When he was stepping down on the liner, the reason being, he wanted to flat drop coming up. So it would come right up. Feels
Somebody. That's me. Dead.
They can work, yeah. What he's got basically the jam running for, we go right into the drain for
Maybe